one thing I have to admit that in last video I have mistakenly told that kinematics chapter is completed, but few of the topics is still to be delivered, is to be explained. So that I will explain it. It may take 2 or 3 classes more, along with some solution that also. But without wasting time, just let me come to the topic directly. The remaining topic will follow from the chapter 7. This is chapter 7 on kinematics. Okay, so kindly be patient and just listen to the topics. So in these topics, first I will describe the kind of motions, or different kind of motions, you can say different kind of motions that are possibly can be divided into 3 basic series or classification, you can say classification. So there are several motion, but the main 3 motions that will include all kind of motions that we see around us or in any part of the space in this universe. So those are, first kind is translatory motion. The second one is your rotary motion. Okay, these are the topic is very general, so I may go a bit fast, so it is not very having very tough to understand. So just follow my my class or my words, it will be very clear to you. And the third one is your oscillatory motion. Okay, so these are the 3 kind which can be broadly classified into three of this kind. So one by one I will bring to you. First one is translatory motion. So translatory motion again can be classified into translatory motion can again be classified into 3 parts. One is linear, other one is curvilinear, and that is random. Okay, so first one is linear. Translatory motion is that if I define broadly on general terms, translatory motion is that where the object is studied under this motion does not change orientation. Okay, so the basic definition of that, where the object which is under the observation or under the study will not change its orientation. The how is that? So it means the every particle of it will move parallel to each other, and does not follow what I say. I'm just rubbing it out because broader qualification you have already seen. Does not follow rotational motion. So the second one that is differentiate the translatory. So there this translatory motion does not contain the rotational motion. So let me explain you with some example so that it will be clear. So if I see, just a kind of object which may be of three-dimensional, if it is moving in a straight line, so that means when it is in translatory motion, so any particle or any part of it will move parallelly. If I see the trajectory of these particles, all will move parallelly, and their orientation, that means this will never, because if I say this is the length and this is the width and there may be depth, so this will never happen that it will turn its face and this will be L there, this will be width there. So that means it is not changing its orientation. Okay, so it will move on the same direction. This may also happen if it is following a curvilinear path. Then also, if I say this is L, this is width, so if it is moved some distance and then after it will width. So this is not changing, means it will not ever come in the orientation. So like this means if it is phase 1, if I say if it is phase 2, this will be phase 1 always outward, phase 2. It will not happen that it will move to phase 2 here, phase 1 here, or something like that. It will not change this way. Okay, so this is orientation is not changing, so still it is moving this fashion, so this comes under translation motion. So this is your linear or rectilinear you can say, and this is curvilinear. Okay, so these are the two kind of translation. The third one, which is comes under this, is the random. This motion is can be studied when a gas is there, when its gas is confined into some contour, or you can say contour, or the fixed volume. Okay, so that means it is kept under a container where the gas particle is randomly moving in any direction, means this can move this way, this can move, and they are changing the direction once two particles collide each other. So after that collision, they may change their direction from this way to any direction. This may come to any direction, or this also striking with the wall, and they may come to any direction. So they are randomly changing their direction, but in every case their motion is in linear way. Even though it is randomly changing, but it is in linear. That till it is being struck with other particle, their movement will be in linear, but it is random. For particular linear, when an object moving, unless and until they are being obstructed or being diverted, they will move. So this is a kind of linear also, but it is random. But why it is happening? Because linear motion, unless and until there is any force is acting, they will not change their direction. So they will move on the same direction in the same speed. Or if it is in any reduction or accelerating motion, that will go on accelerating or reducing their speed. But here you can see striking means they are getting obstructed by something, so that force is acting, because any force acting on somebody, so that object also will rebound. They will give you an opposite force. Okay, so that is Newton's laws of motion. You can know, you can come to know, and I will discuss further laws of that motion that comes under Newton's law of motion. Okay, so that is a different chapter altogether. For here you understand, this is type of motion is called the random motion, where no specific direction you can define. Okay, so this is the translatory motion. The next one is the rotary motion. This differs from the translatory motion by the concept rotary motion. This only differs by the concept when the orientation changing. That means if an object with a fixed reference point moving with equal distant path, that means if it say r of that, this is origin, so any particle is moving. So when it is moving, let's say this is phase 1, this is phase 2. When it is moving at some point of time, if it say the opposite one, you can see that the phase will all opposite would always be outside f1. So if I take this reference point, so that orientation has changed. So now this phase is towards some this direction, this is phase 1. So now it is changing, so the orientation of the phase changing. So for rotary motion, that orientation of phase changes, that differs from the translatory motion. So under this motion there are so many kind of motions can be included, that is spin, circular motion, rolling. Spin means if an object, let's say solid object, moving across a axis, this is axis, and rotating with a circular speed. So when it is rotating, so this called the spin, or any solid body and any ball is being rotated. Circular motion, let's say a person is moving through on a track, which is circular motion. The person is moving that with respect to a center point of the track. This is also circular motion. Rolling means, let's say there is a road roller, on its axis it is rotating, so it is rolling on a ground. So this kind of motion is rolling, where this also is a kind of mixed movement, that with the rolling it will also travel some distance. So these are having rotational motion and rectilinear motion. This is a combination of that, but rolling itself is a motion kind of circular motion. Okay, because if I take any point or any line on that line will move and constantly changing its orientation, it will change its position. So these are the thing. And the last one, that is the oscillation you can say, where the movement of the object is back and forth. So in a particular path, in a fixed path, they will move to that path back and forth. Okay, so let's say this is starting from origin, this is origin, moving towards some direction A and coming back to O, then moving to the opposite direction B and coming back to O again. So this is a complete motion starting from O, moving on the other side back and forth, and again coming back to, unless and until it is compelled upon a force, it will go on moving in the same path. So if this is a kind of oscillation motion, that is linear in motion, there may be possibility that it is hanged upon by a hinge, a ball with a is the rope, you can say. So it will again, if it is disturbed once, it will move to one point. This is the equilibrium point and this is the another point. So against the equilibrium point, it will go back and forth. This is one kind of oscillation motion. Let's say that wire is being tied against two hinge point and it is being disturbed. So they will move within some distance against the equilibrium point back and forth. So this is a kind of also oscillation motion, but this is curvilinear because it is following curvilinear path. This is also a curvilinear path. Sometimes it may happen that a pull fork is being struck by a hammer and it will start moving following some path. This is point of equilibrium and back and forth it will move. So this kind of motion is this again is a linear path. It is following any particle in that object will move in a linear path. This is obviously a curvilinear path. This also follows a curvilinear. So this is a kind of motion which comes under all this, where the positions of the reference, because this is a fixed point position of the fixed point won't move. All particles are following the same curve path. This is the kind of motion that comes under the oscillation motion. Okay, so these are the specific kind, three kind, broadly being distributed in this kind. Okay, now talking further a bit of distance, if I say, so distance and displacement, if I say, so what are the characteristic it is showing when I discuss, that has to be understood. Distance will always be positive. Distance will never be negative or zero. It can be negative or zero. How? A particle is moving starting from a point, it is moved a distance. Let's say it is coming back to that position, but it has physically moved some distance and coming back. So the total distance, it is, even though it is coming back to the original position, but the total distance for forward motion and the backward motion will be added up. So the actual distance or the length it is traveling, that is the distance. So it would always be a positive. The distance is it is can be zero. Sorry, it can be zero. Why it can be zero? Let's say the particle is at rest. So the distance for that it has not traveled anything. So the distance in this case could be zero. So only thing that it cannot be negative. Okay, it always be positive or zero. The zero is the condition where it is its rest, is not moving any distance. So this is the concept of distance. Whereas if I take the displacement, it can be negative, zero or positive. All three can be possible. How? Because the displacement, the definition is that distance, the minimum, the shortest distance travels. So let's say an example, if it is moving from A going to some distance B, by that it has a positive displacement, because if it is stopping their motion here itself, so it has definitely moved some distance. Let's say there, so let's say X, so it is a positive distance, so that will also be called a displacement, because this is the in this initial position and this is final position. So as per definition, the final difference or the distance travels between the initial position to the final. So we will always refer the initial position and the final position. Now it says that initial position and final position merges it. So it is moving through a circular path and coming back here itself. So although it is moving a distance this much, but the initial position and final position is same. So in that case, displacement will be zero. It won't move anything. But some motion, if it say it has moved, started from A, coming back to A again, so this also a merging of the initial point and final point. So in this case, the final displacement will be zero. Further, if it is moving backward after crossing that A point, so in this case, the initial movement, the forward motion will be x, the backward motion will be minus x. Displacement I'm talking about. Now, if it is, because displacement is a vector quantity, it need to have direction. So this way, if I say positive, so this way must be negative, and further going to that, let's say this L, so it will be negative. So my ultimate equation will be this one. So in this case, the displacement is negative. So displacement can be negative, zero or positive. Okay. So in case of rest also, the displacement is zero. So distance and displacement, where it is same, where it is positive or zero. In this case, negative case, because distance cannot be negative, so you cannot compare displacement in that case. Okay, so this is the concept. Moving to some more concept on the other characteristic of the parameters that we will discuss further. Speed, that you know, the distance covered by the time. So it could be a distance covered by time for any segment of a motion, because let's say person is moving in some direction and I calculate time and span of distance covered s. Now it can further move, and with a time of 2t, it might also can S1 S2. Next time this is T1 T2 say. So if I consider this one, so distance will be distance by time for that part. For the next part it will be S2 by S2, but overall that will be, if I want to calculate the speed for that total time, so again it will follow. So that means that total distance, that means the total distance by total time, if I follow it, so even if it is a segment wise, then also follow the total distance S1 by T1. If I take the total distance S1 plus S2 by, so it will generalize, we can say that total distance by total time. This is speed. In case of displacement, it will come velocity, because displacement have direction, velocity have direction, speed doesn't have any direction, So in this case, this will be total displacement. Only distance will be replaced by displacement. So that is the only difference, because that needs to define some direction. Okay. So this will be the case when I will describe that I have already described. So now here comes this speed and velocity, unless it is not changing in direction, if it is a linear, so we can assume that velocity and speed is same term if it is a linear motion. Now there are some differentiation between the different kind of you can say different kind of motion, and this one is speed. So speed can be uniform, it can be non-uniform, and it can be instantaneous. So these are the three kind of speed, and same as velocity if it is rectilinear motion, so we can achieve. So we will talk right now for linear motion, distinguish, because curvilinear I will describe in rotary motion. So in the case of linear motion, speed can be uniform, non-uniform, instantaneous. So how can it be? Let's say a linear motion where the total travel is means distributed into three parts. Let's say three parts. This is T span, this is T span, this is T span. In that, if the distance covered by the object is same, that means for T time it is covered for the first segment S, for second segment also S, for third segment where T, the measurement T I am keeping the same. So if it is the case, so for first case the velocity is S by T, second case also S by T, and third case also S by T. So in that case, that is a uniformity, means equal distance traversed by equal time. So that is called the uniform. When it is said that S against time is constant, then this case the speed will be uniform. In case this differs, that's a S2, S1, S2. So for a same time span, the distance traversed is different. Then in its case the velocity and the speed is non-uniform. So that means I will not get the constant speed in each case. It will be differed, as because S1, S2, S3 are differed. So this is non-uniform. Non-uniform can be a linear in case of circular motion, where the span may be same, because the arc may be same, but as because it is changing the direction, because in velocity case if the changing of velocity changing of direction is there, then that also change the value of the velocity. But in case I consider speed, that will be uniform, but in circular motion velocity will be non-uniform. So the direction will affect the uniformity of the velocity. The velocity, even though if it is same distance traversed, then arc length is traversed, but the direction is changing, so velocity will be non-uniform for circular motion. So just a difference you can understand. And the second one, the third one is instantaneous. In this case, if I want to describe it in a graphical manner, so for a time being, if it is moving with a constant velocity, let's say this part, then after it is changing and again changing, let's say it is with u, it is moving in a span of t1, then after the time of t2, they say this is moving at the velocity v, then after the time of span is constantly changing its velocity, but it is sustaining for certain time. So it is constantly moving, so it is not a straight line. For any uniform velocity, it will be a straight line always, because if I take any span, the change in velocity will be same. Okay, so it will be a straight line. But in case of changing velocity, so the span time, the change, so it will not be a straight line, because from here it will deviate, then further it will move there, from there it will move there, so that will be not a straight line. Okay, so on that I will describe further, because I have to give you more conceptual idea on that. So I will come to the part in the next video. So be with me, so I will continue from this. Okay, thank you.